we can start macros before she comes. So today the class is mainly about macros, but I'll just give parameters how we can combine it. Okay, it's also actually possible to use all four parameters in a single function. Okay, so remember we had this parameters, we went through parameters earlier, and we've done it a couple of times. So I couldn't take this because I was waiting for you to catch up in the understanding the simpler concept, so that we can deal with this thing later. You have to understand this to uh, yeah, talk about this thing. So what do you have here? You can actually use all four parameters. Okay, I'll give you an example. So, okay, A, B, C. I can say optional. And if you're using all of them, this is the order in which you have to define them. D. Okay, and then you can say key. Make sure the keyword symbols are different. And these are the default values. So you can have like 0 is 0 is 0. Okay, name, and then location. Okay, and we can then have ampersand rest for all of the rest of these. So this is the sorry, no, first the required parameters, then option, then parameter, finally the keyword. So you can put the keyword last. Okay, and why this is, you'll have to see it later on, but this is the order. If you want to use all four, okay, use it this way. And the reason why this will work is because okay, the reason why it will work is because key you can actually, you can put it last. Basically you can put the rest and then you can put the keys in. Okay, so I'm just going to return a list plus of A, B, C, D, E. I can do this. Then I make a list of I'm putting values here, which will be default by nil if you don't provide anything, and then name, and then location. Just for so I need at least two parameters, right? 3, 4, 5. Yeah, I guess there is no way of, you should be able to do default here, no? Why is it not giving that? Do we need this key? I guess there is no default for keywords. Yeah, then I have to actually there is no. So optional and rest, of course you cannot give anything. Rest is basically whatever the user provides. Okay, but for keyword parameters, you should be able to do this, right? Why is it not allowing me to do it? Okay, the syntax is not right. Yeah, no, it should allow me to do it. Okay, let's just try it out with the without giving default values. Okay, or let's try out one default value. Yeah, okay. Sorry, there was the again parenthesis issue. There was a parenthesis issue. Let's see. We should be able to give a name. Name. Key name. This should be doable. Yeah. Don't know why this is not working. So this is the way to do it. Okay, my fun 3, but yeah, the 05. Okay, the function name. Okay. Yeah. Sorry, this is the issue. Okay. So because this became an S expression, so this was expecting a value, or what I could do is I should have quoted it like this. Clear? So quote, by the way, there are two ways of quoting it. One is the yeah. So yeah, this is not right because I don't want a, I think I want a list. So this is what I want. Okay. Now it makes sense, right? So this is the way it works. My font for 345. If I put in anything, if I put up to let's say 1, 2, and 3, all of these are optional. They'll get summed up. If I move ahead with 131, 179, this will come into values. Yeah, so that's it's not actually best interest values. Okay, again it's mm, 39, 31. So this is the issue with the combining things, but actually he said that it shouldn't be an issue. Anyway, so let's just do without the key. So I hope you get the issue what the problems that we have when we combine things. Okay, this is the problem that you can face. So when you try it out, you'll know what is the challenges that are you need to face here. So with this thing, you can see that So first you will match so I'm combining optional with the rest. Okay. So today we will not go much more into this. I'll have a look at it again and I'll come back with this. So we have combined three parameters. Okay. Required, optional, and rest. So this is, we can also have keyword symbols, but we have to take care of how it works actually. So we will not do that right now because we don't have time for that. But we can see that we are combining required, optional, and rest values. Okay. So when you do that, the first three are of course required. If I do less than 3, it will not work. Okay. If I have less than 3 parameters, it will not work. So that is the required parameters. It requires you to type in at least 3. But once you type in 3, it's going to work. Okay. Only thing, the values will be nil. All right. The values, you will not have anything there. So it will be nil. Okay. And yeah, optional will be also will be 0. It's the default values. If it was not 0, it would have thrown an error because I'm adding all of them here. So I definitely need a default value. And if it was by default, if you don't put a default, then the default is nil. That will not be suitable here. You cannot put it into this CD thing. Oh, but there are two C's by the way. So that's another issue with the code. So that it seems to be taking the first one. Yeah, it seems to be taking the first one. So you have to also make sure that you name the variables properly, right? You cannot if you override it, this will get hidden or something. That'll be yeah. So the flexibility doesn't give you these things you have to do it on your own. You have to make sure that all your variables are unique and so on. So with combining required, optional, and rest, you saw like what happens here. This is quite clear actually. This is something that is clear because you can see what is happening. I mean, you can reason with it, so it's not so difficult to understand it. So what will happen here is basically, but you can see the options that you have. So first the ABC is mapped to 1, 2, and 3. Since you have D, E, F, you get mapped to this here. Then and this was nil so far. Then you can add in parameters. Okay, this will go into, it will get caught into the values. I hope this thing is clear. So this is how we can combine. So we have combined required, optional, and rest. Okay, and there are some very fine things you can look into it. So we can take it up later. So as you saw, right, this when you start combining the parameters, it can get a little bit involved. So we can look at it later. But basically, you can see that we can combining three parameters, required, optional, and rest, gives you some amount of flexibility in the way to and how you can go about using things. Okay, and I'll give you some exercise on this. So we'll look at it later on. Now let's move on to the exercise lecture today. So for today we will be covering main objective for today is to cover macros. Okay, to go to macros. So what will have what the idea is, okay, let's so this is what I meant here. So typically, so you can actually combine all four of them, but this is very rare. Okay, it's possible but rare. So I showed you how to we combine optional, required, optional, and rest. So typically, what happens is that in functions you have that use multiple flavors. You'll either combine required with one other flavor. So that's why I told you can have a look at it, and at least even if you get good at one each of them individually, you will be good to go. I mean, you will have some idea. You will be able to do some amount of substantial amount of programming, some amount of things you can do. See, for example, REST, you can actually have arbitrary. You can allow the user to define arbitrary arguments. Optional allows you to have between discrete number of things, between n and n plus m, some number of parameters your function can have. So even if you use one of them, one additional parameter, if you are able to understand how it works, it helps you to write functions and to understand existing functions. Then another way is to combine optional and rest parameters, which is what we did just now, right? If you can do that itself, you will be able to do a lot of things with it, optional and rest. And in fact, some exercise I'll give you on this, and you can, yeah, with this you can do a lot of things, right? The other two combinations he's saying you probably avoid it, optional and key and rest and key. So this you have it explained in the book. So people who are interested can go through it, and maybe later if I have time I will take this up. So I will just skip this. Okay. So example is why it becomes difficult. Okay. So we'll skip this for now and we'll move on to the thing. Extending a language, right? When you extend a language, there are two things. One is the core language. What does your language support in terms of low-level things that have to be implemented? This is for language designers. Okay, people who design languages. What does your core language consist of? What are the constructs that are core to your language? Okay, and once you have those core constructs, you usually build up a library of things on top of that will help you to give you basic features. So your language is not just the core language, it's usually a core language with a standard library like C or other languages. So in the language design you have this option. You can make your core language very small and put everything in the standard library. The advantage of having a standard library is implementing the language becomes, one of the advantages is that implementing the language becomes easier. If you want to port it from one architecture to another, say 64-bit to 32-bit to 64-bit, or you want to implement in another architecture, all you have to do is you have to implement those core features. Once those core features are implemented, you can then take care of, the rest of the things the standard library will build in the language that you are compiling to. All right. So if it is C, the standard library is written in C, like sorting, like arithmetic precision, some amount of features are available. All right. So if you shrink, you can. So the users have these. Language designers have this option of either expanding the core language, and if you expand the core language, it becomes difficult to port it to different systems, or you shrink the core language and allow your library to be arbitrary, so that arbitrary in the sense you put all the features into the library, so that it's easier to port things. So this is one advantage of having an extensible language. So that's what is mentioned here. So macros is the approach, is the means by which is one of the major means by which Lisp allows you to extend your language. The core things are very small in Lisp, not very small, but not very large either. Okay, they have a very small footprint, so it's easy to and it gives you this macros option, which allows you to extend the language. Okay, this is one way of extension. So this is one specific way of extension, which is for Lisp, and Lisp uses this macros a lot. All right. So what happens here is standard libraries in the core language, what I mentioned just now. So this is the standard library is something that could have been implemented by any programmer in top of the language itself. So the C language now, if it is a C language, the standard library functions could be implemented by any programmer on that language itself. Okay. All right. So C standard library is can be implemented almost entirely in portable C. So there may be some other constructs that are mixed in, but basically it's essentially C. Okay, so C, you don't have to go into the low-level programming and do anything bit fiddling or whatever in that. You let somebody has to do the implementation, but once you're done with the implementation of the core features, you can always add in the standard library, right? So, and JDK also has this same feature. Okay, so you have a lot of classes that sit with the JDK, standard Java classes, which are basically pure Java. So it helps you to port it to various architectures and various environments. All right, and expressiveness is just a library. Okay, so what happens is it Lisp also allows you to do this. Okay, but it has something extra called macros. All right, so it allows you to create new functional abstractions. It defines hierarchy of classes and gives you macros in Lisp are very different from very how do you say that, very powerful and very much more useful than compared to other. It's not really other macros what you have seen. It's quite different. Okay, it's much more flexible and much more powerful, and that's the reason that we use this to do a lot of things. Okay, a lot of things. So in fact, we will have a look at it in the next slide. So it gives you a totally different kind of abstraction. Okay, so it's all about abstracting things out. This is not really a whether you can do it or you can't do it. It's like how you go about doing it. So this functional abstraction that we saw and kind of the features of the language help you to write macros to do a lot of things. Okay, and examples for that we have. So this is the control structures. Okay, so we have when, unless, can't. Okay, I will now go into this and I'll let you know what this when is. What is the motivation for that? There are other things. So this is Boolean operators. Okay. So another, so I'll just give you an overview of it, what all you can do with the macros. All of these are macros, by the way, all right? So macros is something that at a very high level, a very short summary of what it does. It's basically, it doesn't, this is basically, it's meant to be it's code that generates code basically, okay? At the end, your macro will generate at the bottom level, it will only be a function call and a special operator form. All right, but you as a programmer can write your code in as a macro, and that macro will get expanded at runtime. It will get expanded at compile time, and at runtime you will not have that macro, that definition that you gave will not be there. It will just not be there. It will be expanded down to the low-level constructs. That's what a macro does. So this definition, if you see, it is basically an if function. So I don't know if there are intrinsic functions or if functions are. So functions itself will have, how will they be translated into? Okay. Yeah. So let's just keep it like this. Okay. Basically, what we have is we'll look into the details later on. So details are not relevant right now because what macros does is we have two other forms, right? We have function forms and special forms. All right, we have a functional form and a special form. So special operators, special operator form. Macros is something that you can use as a programmer to write your code at a very high level. Okay, and at the low level there is some very there are 25 special operators in common Lisp. All right, there are only 25 special operators, which is not very small, but it's not very huge also. It's just enough for Lisp, and everything else is either macro or a function call form. So this macro, it will get translated into at compile time, it will get translated into, when you compile the program, the macro will be removed, will be translated. It's like compiling, all right? When you compile, what do? You take a source language and you translate it into a target language. So what will the Lisp compiler do? It will take a macro and it will plug in the definition that it translates into. And the thing that it replaces your macro with will be only consisting of at the end. Okay, there are many, because there are many iterations that it can go into, but at the end, after it's done compiling completely, after it has expanded all the forms, the only thing that will be remaining in that executable or the code that it is going to run is, it will be a function call form or a special operator form. It has to be one of this. All right, and we look at I mean, if you go in depth, we'll know what exactly how it is getting translated and the mappings. But it's enough to at this moment, I think it's enough to say that your macro will be eliminated in the final thing that is going to run. Okay, and this happens for when you compile it. As I said, the Lisp has both. You can do both compiling as well as interpreting. But this example is more relevant for when you compile thing. Okay, and for interpreting, what it does is in the read eval print loop, it's only interpreting. Okay, so there is some amount of overlap in the sense that how it reads this. It has to interpret it, how it reads this thing. It has to actually expand it, but it will expand on the fly, and there are options for it if it is an interpreter. Okay, so there are many ways in which it will go about expanding a form. But at the end of the day, the actual code that you run finally will not have any macro. That's the concept of a macro. So, and these are examples. Okay, control structures. These are all of them are control structures, and yeah. So one example we have here, and you have also Boolean things like or and okay, macros, whereas not is a function. All right. So or and are macros, and not is a function. All right. So we'll have a look at it, and looping is none. So those 25 special operators, none of them support looping. Okay. They only support if, and if is a special operator. But the other operators, none of them support actual looping. All right. So they have but kind of go-to, some go-to thing that they said. So there's some small low-level stuff for branching, but it doesn't have any loop as a special operator. All are macros. So we had a look at this do list. Do list we didn't have a look at it. So I can just show you how do list works. It's very neat thing. Of course, nowadays you have this in many programming languages, but yeah, it's probably the first to come up with this type of thing. It's very straightforward to do it. Clear? So the thing to notice that there's a macro. Okay. Basically, it iterates over all the elements in the list. It will not work because of this kind. So any doubts here so far? So do list is one construct, okay, and similarly you have do times, which we had a look at it yesterday. Just look at this, okay. This is very interesting. The way it does it, and of course we have had a look at do times, but a nice example he has given here. Okay, so what happens here is x is going from 0 to 20, y is also going from 0 to 20. So you just loop as long as it hits this thing. So do list and do times are two macros. Okay, they are two macros, and they in turn call another macro. So it's like two levels of definition, which is a do variable. So you can see here he's saying that yeah. So let me just before we go to do, let's so there is do and there is loop. We'll come to do and loop. We'll just have a look at what is this when, just a motivation of macro. What is this when and unless? All right, let's just have a look at it in a bit more detail, so that we can we can understand the macros a bit better. Okay, so I mean the motivation for having macros. One example of it. So for example, what happens is, so this is clear, right? I hope this thing is clear, how this is getting generated. And yeah, so do times is, I just wanted to see one more thing. So do times is actually built on, it translates into, yeah. So so the implementation can implement these macros as it is, okay, because it is built over the core language. All right, they typically implemented as macros. Typical implementations like common Lisp, I think, I guess the C Lisp what you're using will have the same approach. They are implemented as macros that expand into an equivalent do loop. So this do list and do times will translate into do, and do is much more thing. It provides some more features, okay, in a very succinct manner, and it's also very difficult to get things right, as we will have a look at it. I would like to show an example on that today itself. So, but basically what happens is do list and do times is some kind of simplification over do. Alright, do list and do times. They simplify your, because sometimes this might be enough for you. Either you want to loop over a list, or you want to go like iterate over up to some value integer. So you have this thing, and it's a macro. So macro, it gets translated into do, and do is also not a special operator. It's also a macro. So you have these multiple nesting of macros. One macro gets translated to another macro, and another macro gets translated into the actual code, which will be a special operator or a function call. Clear? So this is the scenario here, and we also have something called loop, a loop macro. I'll just give a short thing as to what this when is doing. Okay, so if I have to have going back to if I put a condition, right? If I put if greater than 1 x, let's say y. Okay, so we had this thing, right? In fact, yeah. So if I let's just take the example that they have here. Let's not create an example. Let's just go with the example they have. So if condition then form, else form. You saw that how right, sometimes you don't want the else form. Okay, it's like this. So for example, spam is what he's saying. If the current message is a spam, right, you want to do something, you want to file in the spam, update the spam database and current message, and you want to do some processing. There is no else part. Okay, if there's no else part, how do you go about doing it? You'll have to put in a progin. You have to encapsulate that in a progin and say do these set of instructions. Okay, but what get it? So let's say I want to print in like this, hello. I just want to give a greeting, and then I said I give the result. X. I just want to, I want to only process one side of the thing. All right. So I want to do this thing. Will this work? So I have a body form star. I don't want the else part. Will this thing work? Because I don't have an else part. All right. No else part. And I want to write a body form star. Will this thing work? The problem with this, there's a problem with this. Okay. And there are, yeah, you can see it in two ways. Okay. First of all, I need to define it, of course. X and Y are not defined. Right. So too many parameters. So I'll define X and Y. X is 1, 0, 1, 9. Y is 1, 5. So 19 is greater than 15. Let's say we had just two forms. Okay. Now the issue with this is basically that, yeah, so okay, now I have only two lines. Now what? I have only two lines. But and what I wanted to, like the spam message, right? If it is spam, I want to do a series of instructions. Okay. So but if I have this, so I have put in the format. Of course, third line was an issue. So second line, what will happen now? The semantics is different now. Okay. Now this I wanted this to be a part of this thing, right? So this will not work because this will not work because of the thing. Hello world and format T. So that I was missing there. All right. So it's syntactically correct. The program is syntactically correct. But what I wanted is, I wanted this to be a part of that greater than. So in order to do that, what I have to do, I have to write it like this. Alright, and close this, close that, and close that. So this is what I wanted. Okay. Else part I don't care. Let's say I don't have else part. Now even if I have to just for the, I know I don't need an else part. Alright, so just a motivation for one example where macros really help. Okay. The point of having a macro. So why do I need this thing, right? Why should I have to define a progin? Progin is little bit. I mean, every time I have to define it, I have to match the parentheses like this. Another extra unnecessary bracket for progin. Okay. So what does when do? When does the same thing. I'll just give you the motivation for when. This is a motivation for when, and it's also motivation for why you might need one of the advantages of having a macro thing. So something that you're regularly typing in, you can save yourself some amount of typing. You don't have to put in the brackets now. You can actually do it this way. So you have a new thing called when, construct called when, and you can actually do this thing. The same thing without one extra command and one extra parenthesis. So to simplify programming programming stuff. So you get it right. I hope the when thing is clear. And in fact, the when is actually a macro, which translates into if. If is a special constructor, and this is the thing. So here is one example, all right, of defining a macro also. So I'm giving a macro definition. So this is how you go about defining a macro. All right. So you say now I'm using my when. You cannot use when because it's already defined. It's a system thing, and it will throw in an error. Okay. Special operator and may not be defined. All right. Yeah. So it's saying special operator, but it's not actually a special operator. It's a macro. Or maybe it's a special operator here, I don't know. But even if it is not a special operator, you can define it like my when. Okay. You saw the point, right? So I can have my own control construct, which does that when thing. So the when is, it seems he's saying it's a special operator. I don't know whether he means special operator or it means a macro. But let's ignore that. Even whatever it is, we can actually define it in ourselves like this. Okay. The way to define it is this way, like this. Okay. So Lisp gives you this thing. So this is the backquote. We'll come back to this definition. Next class we'll have a look at detail into it. But it's a backquote, and you can actually plug in the body. All right. So instead of having to write every time if condition progin, it's basically doing that for you behind the scenes. Okay. And basically I've defined it for myself now. My when. Okay. My when, and I'm using it as when. Yeah. So this is the point of that. And similarly, you have unless. Unless would be like the opposite of that. All right. Unless means that it's going to be like this. So now we have nil. Now let's just put set f x as 5. Okay. Now we have the unless. The unless is similar to when. Only thing, when the condition is false, it will go into that and it will give you that. It will give you the other thing. Okay. It's less than equal to. Unless greater than y. So I can say x as 15, and again this will get triggered. So you can see that it's now, if it goes 16, it will not get triggered. So it's basically, it helps you to write. I hope you see the power of macros here. Okay. And defining macro, the only thing you need to know is this backcode is important thing. And this at the rate of, and we have other, a few more things that you can do in that. So for example, so this is one definition. All right. Do is something we didn't go into. We'll do do and loop tomorrow, and we'll also have a look at this function. All right. So let me just give you an example of another macro. Like what does it take to build a macro of your own? This is my own macro. All right. It's given in the exercise also. I mean in the book. It's given in the book. So what it's doing is it's translating that. We'll discuss two tomorrow, okay, because it's time up. Do is little bit involved, but basically you see this special characters is backquote, comma, and at the rate of, comma at the rate of. All right. So these are the. So you're giving the program itself as this thing. You're giving a let form. So def macro basically what it does is it's like def one, just like def one. All right, you define the, you give the name, you give the parameters, and again parameters could be required, optional, and rest. So here he's taking a rest. All right, most of the time you will be using required and rest, or required and optional. All right, very rarely you'll be using other things, but it's good to know. And keywords also, you can use keywords in some way. It has some lot of benefit of using keywords. But yeah, you'll have one or more of them. I mean, required plus one or one other form. So you can just keep that in mind. And then there's a let form. Okay, let is also proper. You can add functions into your macros. Okay, a macro could be just a function. Okay, you can define a function for a macro. Like for example, I could say something like the same thing, right? Without using the power of macros, I can just say something very simple, like saying plus return for me plus where start and end. But this doesn't take care of the I mean, it doesn't give you any benefit much. Oh, sorry, I defined I'll just keep this 2 times here. But let's just take this my macro, my sum. Okay, you can actually just in terms of definition, it's my sum 0, 1, 2, right? So you get it like this. So you can think of def macro as just another function in terms of the syntactically and structurally. But the whole point of a macro is the way it behaves with the interpreter. What does it give you? And that we have a look at this thing. So you have this backquote wherein you can write, once you do backquote, you can give an arbitrary expression with some special characters. This comma where and comma at the rate of 40. Alright, and these are the parameters that it provides. We'll go into this a bit more in detail. Some of them are special, and yeah, we'll revisit this tomorrow. Okay, so I think it's like we need to take up the exercises. So